Hi everyone, nice to meet you all. I'm Rand, I'm the CEO here at Zama. So today I would like to talk about confidential decentralized AI using homomorphic encryption. So one of the issues with decentralized AI is that by running a public infrastructure, you're exposing all of the user data and model parameters. So for example, if you have a proprietary data set and you want to train a model with it, you definitely don't want everybody to have your data set or to have the weights of the models. You just spend millions of dollars training. So how can we solve that problem and deepen networks in general? So we can use a technology called fully homomorphic encryption, which allows you to compute an encrypted data itself. So as a user, I encrypt my data set, for example. I send it to the decentralized network, the blockchain, for processing. So the validator in the network doesn't have the decryption key, so they have no way of knowing what data they're actually getting from you. But the way the data was encrypted still allows you to do computation on it. For example, train a neural network or run inference on a neural network, and send back the result to the user. So for the end user, nothing changes. They're just sending data, getting a response, but now the data is encrypted when you send it and during computation, so it's encrypted end-to-end. So this is great because it means that you can now have confidential inference, confidential fine-tuning, confidential training on top of any deepened network. Not only does this encrypt the data set and model parameters, it also works with existing decentralized AI protocols because it doesn't require changing the blockchain protocol itself. It's something you're adding on top of your existing deepened infrastructure, effectively. So this opens up a bunch of decentralized AI use cases. I'll give you some examples. For example, you can do decentralized biometrics. If you want to analyze someone's biometric identity, you don't really want that identity to be leaked publicly. So you could do that encrypted by having encrypted database of identities and encrypted input identity from a user and matching one against the other on chain. You could do decentralized advertising where the user profile is encrypted and your algorithm for matching is also encrypted. So I'm not saying we should have advertising in Web3, but I'm just saying that that's possible. Any kind of gaming or game on chain where you want to hide the actual gameplay is also something where you can use this technology. Healthcare, for example, if you want to do encrypted genomics on chain, you definitely don't want people to see your healthcare data. Or if you want, for example, also to create like a data marketplace on chain for clinical trial. This is also something you can do without patients revealing your data to everyone, which is very confidential. Finance in general and marketplaces more broadly. Marketplace is quite interesting because when you think about it, if you sell your data right now, you can only really sell it once because once someone bought it, they can reuse it as much as they want and you're never going to know about it. With FHE, however, you wouldn't actually sell your data. You would sell the result of the computation people want to do on your data. And so because you're not selling the raw data itself, but only the result of the computation, you can keep on selling your data as many times as people want to compute on it. So I think that FHE is a great way to monetize data in general without actually risking the data being reused without your permission. So these are just some examples, but you can imagine how many others might exist out there. I mean, I would even go as far as saying that everything we're doing in the cloud becomes possible eventually on chain thanks to FHE. So at Zama specifically, we spend quite a lot of effort making it extremely easy to use for data scientists so that they don't have to learn anything about cryptography. For example, we've created APIs that bind natively into PyTorch and scikit-learn so that you can use your favorite tools, write code in Python, and we take care of converting that to FHE. So how does it work in practice? Let's take a couple of examples. Here's an example of doing image filtering in FHE. So here we're using a very simple 2D convolutional network. So you define your network in PyTorch the same way you usually do. And then you just have a function that's called compile which basically, you can see it here on the right, which is called compile, that takes your Python code and converts that to FHE, and then you can call the predict function and basically predict unencrypted data. So you can see that the code itself is exactly the same as if it was not encrypted. The only difference is you're calling the Zama library instead of calling the original. Another example that someone did recently with our library is a 23andMe DNA ancestry example. Here, we're not using neural networks, we're using something simple like a logistic regression. So you can see how this works. You just import the XGBoost classifier logistic regression models from the concrete ML library. Basically, just train it in plain text and then convert it to FHE, and then you can start doing predictions. So that gives you a bit of a sense of how easy it is to use for data scientists and how big this could potentially be if you don't have to worry about learning a new language or something. FHE protocols can be secured like any other blockchain. As I mentioned earlier, there is no difference in terms of the blockchain part. This is all running on top of existing infrastructure if you wanted to. So you can have, proof of the FHE computation through consensus, just have multiple validators do it and compare results. You could have optimistic fraud proofs for machine learning, for FHE machine learning. You can have a cut and choose approach where you randomly test a few values to see if people have been honest. And even long-term, why not doing ZK, FHE, ML, although to be fair, this is still a little bit too slow. So one of the big things that people complain about with the FHE is that it's too slow. Well, that's true if you want to do very complicated things, but to give you some idea, FHE for machine learning is today 5,000 times faster than 18 months ago, at least on the Zama side. I don't know about the other people doing it, haven't tried with it though. But on the Zama side, we made FHE ML 5,000 times faster in 18 months. So this is not even like a Moore's law happening. This is like a super Moore's law happening here. And FHE at this point is purely a question of compute. So talking about compute, how do we get FHE to scale to ChatGPT levels? Well, we can use hardware acceleration. So when we started a company in 2020, we could only really do basic machine learning things. Eventually, by creating better algorithms, better engineering, moving to GPUs, we're able to support more and more complex models. But of course, if you want to support things like GPT-3 or whatever, you're going to need some dedicated ASICs. So the same way that you needed GPUs in order for AI to go fast enough, and the same way you needed, Bitcoin miner ASICs for Bitcoin mining to go fast enough, you're going to need a dedicated chip for FHE to go fast enough for most of those applications. So today we don't need accelerators, by the way, to do things like simple smart contract transactions. But for FHE ML, I think we're going to need, or at least for the big models, not for the simple ones, we're going to need some acceleration. Things like trees, things like linear models, they run in real time already today on CPU, so you don't need the accelerators. But for things like LLM, you're going to. So there's a number of companies working on that, and we're expecting the first generation to come out in the next couple of years. And probably, I would say that FHE ML is around 5 years behind in terms of capabilities, model capability and size versus non-FHE ML. So we're not that far behind, and we're catching up very, very quickly. So just keep that in mind. FHE is a solved problem from a mathematical perspective. It's now just a question of compute, and compute is something we know how to scale in general. So what is our vision? Well, our vision is that eventually all of the internet, all of the blockchain applications, everything will be encrypted end-to-end using FHE. So the same way we went from no encryption at all with HTTP to encrypting data we're sending online with HTTPS, we think the next obvious step in the internet protocol evolution will be HTTPZ, where we're encrypting the data with FHE even during computation. And so we think that once this happens, once this HTTPZ protocol exists, nobody's going to care about privacy and confidentiality, not because it's not important, but because it will be guaranteed at the internet protocol level directly.